Hey everyone, welcome to the channel. Today we're diving into a topic, isotopes. By the end of this video, you'll clearly understand what isotopes are and how we distinguish between them. So, let's get started. Before we dive into isotopes, let's quickly refresh what an atom is made of. Take a look at the structure of an atom. Every atom has three main parts: protons, neutrons, and electrons. As you can see, protons and neutrons are located in the nucleus or the center of the atom, while electrons move around the outside. The number of protons determines the atomic number, which tells us what an element of the atom is. Let's take the example of a carbon atom. A carbon atom has 6 protons, which is what defines it as carbon. Now, if it only had 1 proton, it would no longer be carbon, it would be hydrogen. The number of protons in an atom's nucleus is what determines the element. Now, let's talk about isotopes. All atoms of the same element have the same number of protons, but can have different numbers of neutrons, which we call isotopes. Isotopes are atoms of the same element, with the same number of protons but a different number of neutrons. This means they have different atomic masses, but are still the same element. Let's talk about hydrogen, the simplest element, with 3 main isotopes: protium, deuterium, and tritium. Protium, the most abundant, has just 1 proton in its nucleus and no neutrons. Deuterium, also known as heavy hydrogen, has 1 proton and 1 neutron, making it twice as heavy as protium. Tritium, the rarest, has 1 proton and 2 neutrons, making it radioactive. Despite these differences in mass, all 3 isotopes behave similarly in chemical reactions. Let's take carbon as an example. Carbon-12, which has 6 protons and 6 neutrons. We call this carbon-12. But some carbon atoms have 6 protons and 7 neutrons, and this is carbon-13. There's even a third isotope, carbon-14, which has 6 protons and 8 neutrons. Even though their atomic masses are different, all 3 of these atoms are still carbon because they all have 6 protons. So, how does this affect the atomic mass? Well, we know that the atomic mass is the total number of protons and neutrons in the nucleus. Since isotopes have different numbers of neutrons, they also have different atomic masses, which can be seen in the given examples. This difference in mass doesn't change the chemical properties of the element. Carbon is still carbon, whether it's carbon-12, carbon-13, or carbon-14. And that's it for today's video on isotopes. I hope you now have a better understanding of this concept. If you enjoyed the video, don't forget to hit that like button and subscribe for more. Thanks for watching, and I'll see you next time.